Today, Chinese open source AI models are secretly powering up to like 46% of U.S. enterprise workflows.
Yeah, it's wild.
Right. So the artificial intelligence race is no longer this, pristine academic sprint to see who can build this single smartest theoretical brain in a vacuum.
Definitely not.
It is actually a deeply messy, high-stakes battle over who can provide the absolute cheapest digital interns.
It is the ultimate reality check. I mean, we have officially crossed that threshold from theoretical capability to just brutal economic reality.
And that is exactly what we are unpacking for you in this deep dive. Looking at today's massive stack of sources from the tech-reader blog dated Wednesday, July 8, 2026, the signal cutting through the noise is pretty clear.
Yeah, we have a lot to cover today.
We really do. We are going to decode the mechanisms behind why developers are, fundamentally rewriting their daily routing habits. And what specific legal bottleneck is paralyzing the next major wave of U.S. models. Plus, how governments are currently deploying AI to fight automated cyber warfare.
There is just a massive structural shift happening under the surface of the tech industry today. And, the through line connecting all these seemingly disparate events from API costs to presidential politics is entirely driven by the sheer scale of compute.
So let's start right there with the economics, because CNBC just published an investigation that completely rewrites the current narrative.
It really flips everything on its head.
Yeah. The data shows that Chinese AI models now account for an astonishing 30 to 46% of U.S. enterprise AI API token usage.
Which is a massive jump.
Exactly. For anyone listening, just to put that in perspective, the average across the prior 12 months was hovering right around 11%.
Right, which means we're looking at a tripling or even quadrupling of market share in just a matter of months.
Specifically through the Open Rotor Gateway, Chinese model share has actually stayed above 30% every single week since February 8th.
Wow, so it's consistent.
Very consistent. The prime example here is this model called GLM 5.2 from a company called ZAI.
Right, ZAI.
In its first full week after launching on Vercel, GLM 5.2 saw its daily token volume multiply by 27, and its customer count grew 80-fold.
That kind of growth is just absurd.
It really is. But here is the kicker for you. It scored 62.1% on the SWE Bench Pro coding benchmark, which actually beats OpenAI's GPT 5.5 at 58.6%.
Which is huge.
Yeah, and the Chinese model carries an MIT open source license.
See, the underlying logic behind those numbers is what developers are reacting to. This massive migration isn't like some ideological shift.
Right.
U.S. developers are not routing their data through Chinese models to make a political statement. They are doing it because of a fiercely rational engineering calculation.
Pure economics.
Exactly. According to Justin Somerville at OpenRouter, these open-source Chinese models are 60 to 90% cheaper than the leading frontier models from Anthropic or OpenAI.
Okay, let's unpack the mechanics of that, because a 90% discount doesn't just happen by accident. Like, how exactly are U.S. enterprises orchestrating this? I like to think of it like running a massive corporate law firm. You don't pay a senior partner $1,000 an hour to, format a PDF or summarize a basic email.
No, definitely not.
Right. You hire a massive team of highly capable, incredibly cheap interns to do the daily grunt work. And you only knock on the senior partner's door when a truly complex, bespoke legal challenge arises.
That is exactly how the architecture works in practice. It is called the advisor model technique.
Okay.
Over the last year, during what the industry called the token maxing phase, enterprises integrated AI into everything. And they basically burned through their entire annual AI budgets in a single quarter.
Oh, wow.
Yeah, because they were using the expensive senior partners for every single task. Now they have built routing middleware.
So like an automated traffic cop for AI prompts.
Precisely. When an employee queries an internal system, that middleware instantly analyzes the prompt's complexity.
Got it.
If it is a basic request like data extraction, translation, or simple code completion, the router automatically sends it to the cheap, open-weight Chinese model.
And it only escalates it if it needs to.
Right. It only escalates the prompt to the expensive Western frontier model if it detects a highly complex reasoning task. The cheap model is now the default operating system, and the Western model is just the occasional advisor.
But there have to be massive friction points there, right? I mean, you can't just route proprietary corporate data through foreign servers without hitting some serious trade-offs.
You certainly hit trade-offs, which makes that 46% adoption rate even more shocking. Enterprises are willingly accepting data jurisdiction risks by routing through Chinese servers.
Yeah.
They are navigating content restrictions on politically sensitive topics, and they are dealing with reliability gaps in complex tool calling.
But the savings are just too good to pass up.
Exactly. When your cloud compute bill drops by 90% overnight, corporate boards tend to suddenly become very flexible about those trade-offs.
And the Western labs are actively panicking about this structural shift. You look at Anthropic's response. They are currently offering introductory pricing for Sonnet 5 at $2 per million input tokens and $10 per million output tokens.
Which is incredibly low for a frontier model.
Yeah, but that promo explicitly ends on August 31st. To me, that reads like a desperate, temporary play to stop these cheap routing habits from calcifying into, like, permanent enterprise architecture.
It is entirely a defensive maneuver. U.S. frontier labs are effectively watching themselves get priced out of the massive middle tier of enterprise workflows.
Right.
The danger for them is that once a company hardwires its internal router to default to a model like GLM 5.2, it is incredibly difficult to convince them to switch back, even if you lower your prices later.
But while enterprises are aggressively rewiring their daily operations to save money today, the top-tier U.S. models that could theoretically win back that workload are currently legally trapped in a waiting room.
Yeah, the regulatory landscape is a mess right now.
The regulatory apparatus in the U.S. just hit a massive, sudden bottleneck.
This is where the sheer speed of enterprise adoption violently collides with the reality of government bureaucracy.
Let's lay out the facts from the sources. President Trump abruptly canceled a scheduled Oval Office signing ceremony for a new AI executive order.
Right, which caught a lot of people off guard.
Definitely. And he cited concerns that signing the order would undermine America's lead over China.
That was the stated reasoning, yeah.
And the backdrop here is crucial for you listening. The banking and financial sectors were heavily pressuring the administration to sign this executive order.
Because they are deeply terrified of the cybersecurity capabilities they are seeing from models like Claude Mythos.
Right. They know these frontier models can be weaponized.
Exactly. The financial sector understands that these models can automate cyber attacks at a scale we have literally never seen, so they wanted formal guardrails.
So, with the signing ceremony canceled, what does this all mean? Does the entire regulatory framework just, vanish? Do the major tech labs just get to push their next generation models out the door tomorrow with zero oversight?
No, not at all. The regulatory framework is still very much intact, and that is exactly why the industry is paralyzed right now.
Interesting. So the cancellation was just a process then?
Right. It was a shift in political process, not a collapse of governance. There is an older, existing executive order from June 2nd that contains hard statutory requirements.
Okay, what kind of requirements?
Well, specifically, it legally binds the NSA and CISA to deliver a classified frontier model benchmarking framework, along with a voluntary pre-release framework, by August 1st.
Meaning that August 1st deadline is a baked-in government obligation. It happens regardless of the canceled photo op.
Exactly. And that immovable deadline is dictating the entire product roadmap for the Western AI labs.
I see the logjam now. Everyone listening who follows this space knows we are actively waiting for OpenAI's GPT 5.6 suite.
Yeah, the Sol, Terra, and Luna models.
Right, and Google's Gemini 3.5 Pro. But those models cannot launch right now.
They are completely grounded.
Because if Google or OpenAI releases a massive frontier model broadly, without waiting for that August 1st NSA framework, they expose themselves to, catastrophic export control risks.
Yeah, the legal exposure is massive.
We literally just saw this happen when Anthropic's Fable 5 ran face first into those exact export control walls.
It really is a deeply ironic situation.
Yeah, so.
Well, the regulatory pause is meant to protect American interests, right? But it's actually preventing U.S. labs from releasing the exact tools they need to win back the enterprise market from the Chinese models we discussed earlier.
Oh, wow. Yeah, that is incredibly ironic.
The mechanism of those export controls is tied to compute thresholds and capability benchmarks. Until the government officially defines where the safety lines are drawn in that upcoming August 1st framework, launching a massive new model is a game of legal Russian roulette.
So August 1st is the undisputed starting gun for the second half of this AI race. But bad actors are not waiting for an August 1st government framework to launch their own tools.
No, they certainly aren't.
Which pivots us to the reality of active cybersecurity. Because while the models are trapped in a regulatory waiting room, the cyber threats are already in the wild.
The theoretical risks that the banking sector was worried about are now active daily realities for network defenders.
And the sources highlight a fascinating practical response to this. The government of Alberta just became the first Canadian province to publish a formal AI cybersecurity case study. They are actively deploying Anthropic's Claude directly inside their government security scanning workflows.
The mechanics of how they are using Claude are highly revealing. I mean, they aren't just using it as an interactive chatbot to ask security questions.
No, it's way more integrated than that.
Right. Claude is autonomously scanning vast code repositories, prioritizing the discovered bugs based on actual exploitability and severity, and then generating candidate software patches for the highest priority vulnerabilities.
And then producing audit-ready documentation for the human oversight teams.
Yeah.
Which is wild.
It really is. And Alberta is reporting that this dramatically reduces their mean time to remediation.
But we have to look at the broader context of when this case study is being published. Anthropic pushed this deployment into the public eye just 1 week after the JDPuffer AI ransomware disclosure.
Right.
And this was right in the middle of a Five Eyes intelligence warning that major automated AI cyber attacks on government infrastructure are just like months away.
The timing there is perfectly orchestrated. I mean, Anthropic is using the Alberta deployment as tangible proof of what they call the defensive AI thesis.
Which argues that the only way to stop a frontier model is with another frontier model.
Exactly. The core logic of the defensive AI thesis is that the massive parallel processing capabilities that make AI ransomware so dangerous, well, those are the exact same mechanisms required to defend against it. You know, you simply cannot stop an automated machine speed attack with manual human code review. You have to fight fire with fire.
Okay, here is where it gets really interesting, but also a bit scary for you listening. Let me push back on the mechanics of that thesis, because for anyone who manages network security, this sounds like a terrifying treadmill.
It definitely can be.
If an AI-assisted threat like JDPuffer can probe a network's attack surface 1,000,000 times a second looking for one microscopic gap, isn't a defensive AI scanner fundamentally at a disadvantage?
How do you mean?
Think about it. A human security team is like a single guard with a flashlight patrolling a massive warehouse. Alberta upgrading to Claude is like hiring 1,000,000 automated security guards who can read every line of code in the building simultaneously.
Okay, that makes sense.
But even with 1,000,000 guards, if the attacker is also an AI generating infinite novel attack vectors, defense still has to perfectly patch every hole, while the offense only has to be right once.
Yeah, that classic asymmetry.
Exactly. Can an AI defense actually outpace an autonomous AI offense?
That is the defining cybersecurity question of the decade, honestly. And your skepticism hits the exact flaw in the current model.
Cool.
Alberta's AI deployment is highly credible because it shrinks the window of vulnerability. By reducing the time it takes to patch a known bug, you limit the attacker's opportunity.
Right.
But you are absolutely right about the structural disadvantage. The defensive AI thesis assumes that the defender's model can predict or react to the offensive model's novel strategies fast enough.
Which might not be true.
Exactly. True autonomous threats, which don't rely on known ransomware signatures, are going to stress test whether AI defense can ever truly achieve parity with AI offense.
It is a terrifying arms race playing out in real time. And when you zoom out and look at the broader ecosystem surrounding all of this, the sheer scale of the capital and compute required to fuel this arms race is forcing desperate maneuvers across the entire industry.
Yeah, every single data point we have left to discuss is fundamentally a symptom of the same underlying condition.
A massive industry-wide squeeze.
Right, a squeeze between the soaring physical cost of hardware and the desperate need for software efficiency.
Let's connect those dots. Because on the hardware side, SK Hynix is currently planning a massive $28 billion US IPO.
A huge move.
Yeah, and it's specifically for their HBM memory chips, which, are the critical high bandwidth chips that feed NVIDIA's GPUs.
Right, you literally can't build the data centers without them.
Exactly. And at the same time, Jefferies is warning that standard DRAM memory prices are going to surge 40 to 50% in the third quarter alone.
Just massive price spikes.
And it's purely driven by AI data center demand.
See, the physical backbone of AI is just becoming prohibitively expensive.
Okay.
When the basic raw materials like those memory chips spike in, cost by 50%, that financial burden rolls directly downhill to the software layer.
Which perfectly explains why a trillion-dollar company like Microsoft is doing what they're doing. I mean, they are currently evaluating a fine-tuned tier of the Chinese DeepSeek V4 model to host on Azure for their Copilot features.
Which is just stunning when you think about it.
Right. Even the hyperscalers are feeling this compute crunch so severely that they're like looking to foreign open weight models purely as a cost reduction measure.
It is an incredible validation of the enterprise mogadishan we discussed in that first segment. I mean, if Microsoft has to compromise just to maintain their margins, imagine the pressure on a standard enterprise.
Oh, for sure.
This compute crunch also explains why Google is reportedly struggling so much with the token efficiency of Gemini 3.5 Pro.
Leaving it stuck in a limited preview with no general availability date.
Right. Making a model smart is one thing. Making it cheap enough to run at scale without bankrupting the company is the real bottleneck.
And the financial scale required to solve this compute crunch is reaching sovereign nation levels. OpenAI just formally proposed a $42.6 billion government equity stake.
Wow.
Yeah, and it's structured exactly like the Alaska Public Wealth Fund, where the government would basically take a 5% share.
They are essentially pitching a nationalized funding structure because the traditional venture capital markets simply cannot sustain the capital requirements of the next generation of data centers. They need nation-state backing to afford the hardware.
Meanwhile, the regulatory and security tightening we talked about earlier is causing friction everywhere else.
It really is.
The proposed $20 billion merger between Cohere and Aleph Alpha is completely stuck in regulatory review with no timeline.
Just frozen.
Yep. And Anthropic's Fable 5 is finally back online, but they were forced to implement strict government-issued ID verification via persona just to satisfy their export control agreements.
Which adds so much user friction.
Exactly. And over in China, their new AI companion law enforcement hits on July 15th, which is forcing the complete shutdown of the Dubao agent.
So if you synthesize this entire landscape, the narrative is undeniably clear. The tech giants are aggressively maneuvering through strategic hardware acquisitions, desperate efficiency plays, and massive sovereign wealth pitches just to survive this economic squeeze.
While holding their breath for the regulatory floodgates to open on August 1st.
Exactly.
It is a precarious high-wire act with hundreds of billions of dollars on the line. So let's bring this all together for you. If you're trying to stay well-informed, the real story of July 2026 isn't a philosophical debate about when we will achieve artificial general intelligence.
It is ruthlessly pragmatic.
Exactly. It is about the harsh reality of Chinese open-weight models undercutting the Western market by 90% and just swallowing the enterprise workload.
Yep.
It is about the entire U.S. artificial intelligence industry being legally paralyzed, waiting for an August 1st national security framework before they can counterattack. And it is about the frantic real-time deployment of AI security guards to defend critical infrastructure against automated cyber warfare.
Which leaves us with a fascinating and frankly chilling final implication to consider about that cyber warfare dynamic.
What's that?
We talked about Alberta using an AI to scan code and autonomously generate security patches, right?
Yeah, which seems like a huge advantage today.
It does. But if defensive AI models are actively writing our security patches and their behavior is ultimately based on predictable algorithmic patterns, what happens when an offensive AI learns to deliberately insert novel vulnerabilities that look exactly like the quote-unquote fixes the defensive AI is trained to apply?
Oh, wow. Wait, really?
Yeah. We could be rapidly approaching a reality where the offensive AI doesn't even try to break through the shield.
It just tricks it.
Exactly. It just poisons the data the shield uses to repair itself, turning our automated defenders into unwitting accomplices.
That is a phenomenal and, frankly, slightly terrifying concept to mull over. What happens when the automated security guard starts trusting the intruder more than the architect?
That's a dark thought.
That is something you will definitely want to chew on. Thank you for joining us for this deep dive into the sources today. Keep questioning the consensus, always look at the underlying mechanics, and we will catch you next time.